Hello everyone. Today I'm going to discuss about queue. Queue is another important data structure like stack. Okay, and to talk about queue, it's the concept is pretty much simple, right? Now, like in a real life scenario, you went to a hospital, you are standing in a queue, one after another, you are getting attended. So similar kind of concept also applied in programming, and the same concept has been implemented as a queue data structure. Okay, unlike stack, queue has two different pointers. If you have already went through my stack video, so you already know there is one single pointer in stack and that is called top. But for queue, we are going to have two different pointers. One is called head, another is called tail. The data insertion happened from the head end and the data popped out from the tail end. Okay, so from let's say like we have to insert 1, 2, and 3, right? So 1 is going to be inserted first, then 2, and then 3, right? So from tail end we will access 1 first, then 2, then 3. So that is why queue is called first in first out, or rather from the queue concept of real life example we'll say it like first come first serve, right? So there are some patterns and anti-patterns where we can use queue, where we cannot use queue, right? So in terms of most of the recursive problem, most of the collection-based problem, we can use queue. But if there is any program or there is any challenge where we have to create a data structure, we have to use a data structure like and where we can have a direct access to a memory block or to a particular element. That's definitely in those cases queue is not very effective, right? Because in queue, if I have to access 3, then I have to pop 1 and 2 first, then I can have my hand on 3, right? So it's a sequential access, and that's a big O of n, right? And that's why queue is not very effective in those use cases. Okay, so let's see how we can implement queue using Python. First things first is I have I have already wrote down a couple of code, and I will take you guys through that what those blocks, what those methods, and all those stuffs mean, right? First things first is annotation. Okay, so annotation is very important in terms of modern days programming, and I know it's a best practice. We should all follow that. If you don't know what is an annotation, I would say like Google it. You will find it way better than my jibber jabber talk. Okay. So coming to the queue class, first things first is our queue. I mean, similar to stack, queue is also an ADT, like abstract data type. So we cannot access the elements of queue directly, or we cannot access the pointers of queue, like the head pointer and tail pointer, or we can even know like what is the size of the queue directly by just accessing the method variable, instance variable. Okay, so that's the level of encapsulation queue provide, and we have to use the inbuilt methods. And again, queue is not a dynamic array, it's static, so we have to mention the size beforehand, and that's what I have just did here. Like I have, taken a size variable and I have used it like this. Okay, everything is implemented as a private variable, okay, so that it cannot be accessed outside. Although in Python, unlike Java, we can access the private access specifiers, I mean the private methods or the private variables of an object from outside. Okay, that's a bit of a thing I will explain later on. To know the size of the queue, I have implemented get size to know the head pointer where the head pointer states. It's the get head, and similar like get tail. So when our queue is empty, let's get back to the whiteboard now. Let's talk about this thing. It's an empty queue, right? It's an empty queue. Okay. And when our queue is empty, both head pointer and tail pointer, they are at -1, right? So when I insert one single element into the queue, both of them will be increased. So the head pointer is going to be 0, the tail pointer is going to be 0. The idea is after that, when I insert another record, the head pointer will stay at 0, but the tail pointer will go up to n minus 1, where n is the size of the queue. That's the idea. Okay. Now, we will then now it's time to implement the push and pop. So for push, we are going to insert an element into the queue and is going to return us none. So first things first, we are going to check if the queue is full or not. So if self dot tail equal to -1, okay, then we will raise an exception, and the exception is going to be queue is full. Yep, queue is full. Can't do anything, right? Sorry, not -1. That should be self dot size -1. Okay, queue is full. We cannot do anything else. What I just said. First thing is elif elif self dot head equal to -1. Then self dot head equal to -1. That means there's a first element I'm going to insert. So I'm going to do self head plus equal to 1. Okay, and self tail plus plus equal to 1. Okay, else self, okay, that might be self dot, I forget a dot here. Oh, self dot, we are going to increase the tail pointer by 1. Okay, at the end we are going to insert the element into the queue. Okay, self dot tail -1, sorry, self dot tail, and that should be the element. Okay, now our push has been successful. So let's talk about pop now. Pop, we cannot do any pop operation if our queue is empty. That is the first thing, right? So let's implement that scenario. If our Let's check if our queue is empty or not. If self dot head, let's talk about the head pointer. If that is -1, we can raise an exception simply. No, nothing we have to worry about, and we'll just say, hey, our queue is empty. What are you gonna trying to do? Popping from an empty queue? That's not a good idea, right? So if it is not, if it is not, now let's go back to the dashboard. Okay, I'll show you guys a scenario. Okay, let's talk about this three element. One get inserted here, then two inserted, and three inserted. Our tail pointer lives here, head pointer. Now what we are going to do, what we are going to do is we are going to access from this side. So at some point, tail and head, both of the pointer, when we retrieved all the elements, then both head and tail pointer, they points to a same number. It can be the end of the queue, or it can be the beginning of the queue, which is 0. So either it can be 0 or n-1. Okay, that scenario we need to handle. Okay, so if I head back here, if I just write like the first things, else is, we'll just temp, and that is going to be self dot uh, queue, and I'm going to put self dot head. Okay, and I'm going to return temp, but before that I'm going to do self head plus equal to 1. Okay, or what we can do, we can retrieve the tail. Okay, we can retrieve the tail, so decrease the tail. So that's up to you how you're going to implement that, right? And return temp. Okay, So elif, that's this is a special case I was talking about. Self dot head equals to self dot tail. Then what I'm gonna do, I'm gonna first things first is temp equal to self dot queue, and from there I'll just put the last element should be, and then I'm going to put self dot head equals to -1, and similarly self dot tail should be -1. That means our queue is empty and ready to be inserted again. But there is a problem. We are retrieving the element, okay? We are retrieving the element, we but we are not assigning none to that particular block, right? So it's a good time to we should assign none to that particular block, right? So let's do it. That should be none, right? Similarly, we are going to do it here as well. So our queue implementation has been done, so it's time to test it, right? So we are going to create a object of our queue class, and I will just create a size of 4. So let's print the size first, okay? Fantastic. After that, let's insert an element, right? Let's say push push 1, then 2, then 3. Okay, then just do the pop, right? Okay, now it's time to execute. Okay, oh my bad. I forget to print. Now let's print it. Yep. So if you see, I pushed 1 first, then 2, then 3, right? So when I retrieve, 1 is retrieved first, after that 2, and after that 3. That's so this is how queue works, right? So I hope you guys have understood like the concept of queue, how it is implemented. I can assure you guys that no one is like 95% interview, no one is going to ask you to implement queue using python or whatever the language you prefer, right? Because it's very unusual one. That interview should be a very unusual interview, but I don't say there is no possibility, but the possibility is very less. The main aim for of this video is for you guys to understand or the grab the concept of queue, because in the upcoming videos where I was actually I'm going to solve all the lead code problems. There I'm going to use queue heavily. Okay, so lot more new videos to come. So till then, goodbye.